Welcome to Activity 35. Today we are going to talk about using matrices for transformations, particularly to translate and to reflect. First of all, when we are looking at points or different figures to translate or reflect, we can organize our data as a matrix, particularly as a row matrix, or what we will be using more often, a column matrix. So again, a row matrix means you would have a 1 by however many pieces of data versus a column, which would be one column, and then your rows would be different depending on the amount of your data. Now, when we are given shapes, for instance, a triangle, we can organize our data as either a row or, again, in this case, a column matrix where we organize each point stacked x over y, and we can then even combine these so that they are one singular matrix. So we have the different x coordinates, so number 1, 2, and then 3 stacked on top of each other, and then we can translate or reflect using that column matrix. Now for translations, this is going to go back to the idea of our addition, or you could think of this as subtraction if you are shifting down or to the left. And again, you would have to make these movements to each of the coordinates. The x's are going to be moving horizontally, the b's are going to be moving the y's vertically. Again, if you have a positive a, it would move it to the right, a negative a would move it to the left, and then vertically, positive b goes up, negative b goes down. So when we have our first triangle, ABC, again, we saw up above we can stack A, B, and C as our column matrix, and then in order to show that movement to the left, okay, we would be adding onto it a negative A value, so left 4 would be represented by a -4 for each of these, and then the up 7, we'd be adding on 7 for our final matrix then, that would be written as each of these being subtracted 4, so -3, -1, 1, and then each of these would be added 7 on, so 9, 11, 8. On our next one, we are then going to also be able to talk about reflecting. So there are two different matrices for the reflecting over each of our axes. For the first, on the x-axis, notice it is 1, 0, 0, -1 here. And then for the y-axis, the -1 comes first, then 0, 0, 1. Remember, when you are reflecting over the x-axis, essentially you end up changing the sign of your y, versus reflecting over the y-axis, you end up changing the sign of the x. Okay, because remember, x-axis, you would be going up to down, for instance. Y-axis would be shifting across. So when we perform these, we want to each time take our matrix that we would be reflecting, in this case, the x-axis. This would come first, so that the operation could actually exist, because this is a 2 by 2, and we have our 2 by 3 matrix, that column matrix, so 1, 2, 3, 4, 5, 1, and when we multiply these, what ends up happening is, again, we end up changing that y value as we go through, becomes 1, 3, 5, -2, -4, -1. For the second one, as we reflect over the y-axis, this time we would be using -1, 0, 0, 1 for our reflection across the y. Again, multiply by our triangle column matrix, and then this time when you reflect the y, what ends up happening is essentially your x values end up flipping signs, y values stay the same. Now, reflection across both axes would end up having both our x and our y changing, so we would actually have the -1 in both spots. And again, as we set up our column matrix, when you multiply this out, everything actually ends up changing signs. to show that reflection over both axes, or sometimes you see that called a rotation 180 degrees. All right, thanks everyone for watching. We'll work more with these in class.